Chapter 9 is that we want to be able to use the quadratic formula to solve quadratic equations. And for those of you keeping score at home, this is 9-5. So I'm going to do one quick example here, and I got a couple more examples forthcoming as well. So your target is that you want to be able to use the quadratic formula to solve quadratic equations. And the first thing we need to know, if we're going to do that, is we need to know the quadratic formula. And the quadratic formula is, or says, that if ax squared plus bx plus c equals 0, and a is not equal to 0, then x is equal to this mess right here. X equals negative b plus or minus. This thing right here is a plus or minus sign, meaning that we are going to add, and then we are also going to subtract. So we'll have two separate answers, and that's a result of this square root, because then we will take the square root of b squared minus 4ac divided by 2a. So quite the mess, but I'll give you an easy way to remember that here at some point in time. But for now, that's what that quadratic formula is. It helps us solve for x. And why do we have that? Because if we try to use algebra as we know right now to solve an equation with an x squared and also with an x in the equation, it becomes very hard to do. And the things that we know how to do, like use train tracks, if we call them train tracks, or just using the processes of algebra or guessing and checking, it doesn't work. So we need something else to put in our toolbox to be able to solve this equation. And the only way to do that is, unless you get lucky and guess what x could be, you have to use the quadratic formula. So we're going to use this thing whenever we have a quadratic equation. And this formula can be used to solve any quadratic equation. That is, unless b squared minus 4ac underneath the square root here is a negative, because we cannot take the square root of a negative number. So let's get into some examples here. The first example that we're going to have is that we're going to solve x squared plus 8x plus 7 is equal to 0. We're going to solve this equation. And once again, if we try to use train tracks or algebra or to get x alone, it's not going to work, and that's because of the fact that we have an x squared and also an x in the equation. So the processes we know aren't going to work. We can't use train tracks. We can't get x alone. We don't know how to isolate x and get x by itself because we have an x squared and an x. And if you don't believe me, go ahead and try it. And it's not going to work. So we're going to use the quadratic formula. And in this case, we notice that this equation is set up exactly in this format. ax squared plus bx plus c equals 0. ax squared plus bx plus c equals 0. The only difference is we're missing an a and a b and a c. And the reason we're missing an a and a b and a c in this equation is because a and b and c have been replaced with numbers. In this case, integers. So what we have here is a is 1, because the number in front of x squared, the coefficient of x squared, is 1 because there's no number in front of the x squared. So a is 1, that's where we get this a is 1 right here. B is 8 because 8 is the coefficient of the x, just as it is laid out in the standard form of a quadratic equation. And c is equal to 7 because we have the plus 7 plus c is right there, and it all equals 0. So it maps out very nicely here. So now we're going to use the quadratic formula. We have our a and our b and our c, and now we're going to use the quadratic formula, which is this right here. This is just the quadratic formula. Remembering that will be a little difficult at first here, but once we use it several times, it'll be fairly easy to remember. And what we do from here to here is we've just plugged in all the values. Negative b, well, b is 8, so we plug in 8 for b, plus or minus the square root of b squared, so this 8 is the b, minus 4 times a times c, all divided by 2 times a. So all we've done is plug the values in. And now we're going to evaluate by using the order of operations. So we follow the order of operations, and we're going to work under the radical sign, or the square root symbol, with its unwritten parentheses first, because once again we have to simplify what's inside the square root before we do anything else. So this 64 right here comes from 8 squared. 8 squared is 64, so that's where the 64 comes from here. Minus 28 comes from the 4 times 1 times 7. 4 times 1 times 7 is 28, and we are subtracting that, so we have 64 minus 28. And the negative 8 is still there. The divided by 2, or it's a 2. Why is it a 2? Because we had 2 times 1 in the denominator. So we have the times 2, or divided by 2. And then we simplify further. 36. Now, where does 36 come from? 36 comes from the 64 minus 28. 64 minus 28 is 36. So now we've simplified what's underneath the radical symbol or the square root. So start a new sheet here. The square root of 36. What is the square root of 36? I know that because 36 is a perfect square. It is 6. So what this means now is that x is going to be equal to negative 8 plus 6 divided by 2, or x could be equal to negative 8 minus 6 divided by 2. Why do I have two possible values for x? Why do we have this or this? Because of this plus or minus. Because technically there are 2 square roots of 36. And those 2 square roots of 36 are positive 6 and negative 6. Because 6 times 6 is 36. And negative 6 times negative 6 is 36. Surprised you didn't know that. Moving on here, folks, moving on. So now we do some simplification, and we get x is going to be equal to negative 2 divided by 2. Where does this negative 2 come from? It comes from negative 8 plus 6. Negative 8 plus 6 is negative 2. Negative 2 divided by positive 2 is negative 1. Or we have this instance over here. Now we have a negative 14 divided by 2. Where does negative 14 come from? Negative 8 minus 6. Negative 8 minus 6 is negative 14. And negative 14 divided by 2 is negative 7. Therefore, our answer to the quadratic equation that we were given is negative 1 or negative 7. That means that if we plug in negative 1 or negative 7, we can't do them both at the same time, but if we plug them into the equation we were given, the equation will be a true statement. So we have 2 answers here. Quite a bit of work. Quadratic formula, not easy to remember, but as we work with it more, it will become a little bit easier to remember, and the work becomes a little bit easier as well.